Welcome to Lesson Up, math tips, tricks, and other ideas. To help continue expanding this site, don't forget to subscribe and like. Consider this problem. At the receptionist's desk at your doctor's office, there is a bowl filled with 30 lollipops. 15 are grape-flavored, 7 are lime-flavored, and 8 are cherry-flavored. Leaving the doctor's office, you randomly grab 3 lollipops. What is the probability at least 2 are the same flavor? If you'd like to try this problem on your own, you should pause this video now. Counting techniques are certainly an integral part of determining basic probabilities. It's difficult, or nearly impossible, to determine the probability of an event occurring when we can't confidently count the number of occurrences. However, in my courses, once students are comfortable with counting techniques, another element to their probability dexterity rears its head, and that is the complement of a probability. Certainly one of the more pronounced difficulties students have with a problem such as this is placing it into context and then confidently knowing how to proceed. As the problem is presented, a red flag appears that offers a big clue how to take action. The phrase "at least" translates to as many or more. When instructing students, what this means for this problem is grabbing 3 lollipops in which 2 or 3 are the same flavor, and they certainly get this concept. Now instinctively, they know that there are 30 choose 3 ways of selecting the 3 lollipops. However, to determine the probability, they set about calculating the combinations for each outcome and summing the results. Now this is a feasible approach, but ignores the context and thus the understanding of utilizing the complement. As an equation, students know how to calculate the complement. The trouble is they don't understand what the complement is describing. Their contextual ability is their downfall. Nonetheless, just viewing this process, along with the phrase "at least," patently hints that there must be a better way to determine the solution. With this supportive insight, eventually students see that the complement for this scenario is none of the flavors are the same, or to put it more plainly, there is 1 lollipop of each flavor. Determining the complement to this outcome certainly enlightens their understanding. But should it be this sophisticated for students to put all this together in context? Consider this revised scenario. At the receptionist's desk at your doctor's office, there is a bowl filled with 40 lollipops. 15 are grape-flavored, 7 are lime-flavored, 8 are cherry-flavored, and 10 are lemon-flavored. Leaving the doctor's office, you randomly grab 4 lollipops. What is the probability no more than 3 are the same flavor? If you'd like to try this problem on your own, you should pause this video now. Students should recognize that the complement is introduced in the form of no more than. Phrases such as at least, at most, no less than, more than, fewer than, all conjure up a complementary form of calculating a number count, and students need to spot that such a phrase plays a key role in the process. Again, students know that there are 40 choose 4 ways of selecting 4 lollipops, but there are 35 different outcomes of grabbing the 4, in which 31 have no more than 3 flavors. Though it is possible to list all these outcomes, as we can see, it's very impractical and certainly not necessary. The complementary phrase "no more than" should keep students from pursuing this route. Naturally, the complement to this scenario is all 4 lollipops are the same flavor. This simple contextual connection certainly affirms our understanding and makes our work much more reasonable. And of course, that's the objective. To help continue expanding this site, don't forget to subscribe and like. Thanks for watching.